Hello, my name is Jeffry Simpson, and Group 1 has chosen unit testing for our presentation. So what is a unit test? The IEEE Systems and Software Engineering vocabulary defines a unit test as the testing of individual routines and modules by a developer or an independent tester, and also the test of individual programs or modules in order to ensure that there's no analysis or programming errors. You can think of a unit test as the basic most level of testing in a software application. In the next slide, we'll look at how it fits in with other types of testing. Unit tests can be seen here as the base of the test automation pyramid, originally introduced by Mike Cohn, one of the contributors to the invention of the Scrum software development methodology and one of the founders of the Scrum Alliance. On this slide, you can see two examples of the test pyramid taken from different software development sites, including Google's Android Development Guide. The pyramid shows an idealized distribution of automated tests at the various different testing levels. As I said, it starts with a broad base of unit test and ends in a focused peak of mainly manual acceptance or exploratory test. This pyramid represents one of the standard testing patterns in the software industry. In contrast, on this slide, we see the inverted pyramid, also known as the software testing ice cream cone anti-pattern. It illustrates the situation when only a few unit tests are available, and how a project would struggle with making up for this deficiency with costly automation system-level test and resource-intensive manual regression testing. Having been in the software quality industry for 25 years, I've seen this anti-pattern in many commercial applications under test. So when do you create unit test? Klaus Klamer and Alban Kern presented at the 2015 IEEE 8th International Conference on Software Testing their research on unit testing as they investigated tests written for a large industrial software program written in Java over 10 years. They found that the easiest way to ensure testability is to write unit tests in parallel with development, and that it was unlikely that old untested code would ever get covered by appropriate unit tests later in the development cycle.
Hello, my name is Josh Higgins, and I'll talk about on this slide a survey that was done on companies that use unit testing practices. So a unit test is a test that is executed by the developer in a laboratory environment that should demonstrate that the program meets the requirements set in the design specification. They found in this survey that companies with unclear definitions of the unit tests to run are at a higher risk for inconsistent testing. So, with a clear and shared understanding of the specific environment and what testing is to be accomplished, the different stakeholders will understand better and accept the responsibilities that comes with the unit test. This slide will talk about what we experimentally know about unit testing. Testers can also use testing criteria to evaluate test sets. As with test generation, the commonly used criteria are based on data and control flow mutation and their variance. Regression testing techniques are the most widely used for selecting test cases from an existing set. Testing techniques follow different strategies or criteria to create, evaluate, or select a set of inputs to run a program that looks for faults.
Hi, I'm Lavold, and I'd like to talk about caveats to consider when doing unit testing. With unit testing, more is not always better, especially when considering how much unit testing should be performed. Code coverage, a percentage of tested code, is often considered when performing unit testing. Determining what units of code should be tested and how much code coverage is needed can be a difficult thing to nail down. Ericsson, a telecommunications company, evaluated how well its unit testing coverage efforts were performing. Surprisingly, the Ericsson study found that high unit test coverage didn't seem to provide any tangible help in producing defect-free software. Another caveat is that stakeholders can perceive a false sense of code quality. Due to the lack of empirical data, Ericsson researchers concluded that unit testing's effect on code quality is questionable. Interestingly, the Ericsson study also noted that increasing the unit test coverage did not necessarily decrease the number of defects. Increasing the coverage only created a slight tendency towards decreased defects. As with all testing methodologies, unit testing is costly and can be cost prohibitive. Testing requires resources such as people, time, and money. Test code must be maintained and occasionally updated when impacted by software code changes. This ensures the unit test remains valid and useful. When testing resources are scarce, developers can be tempted to limit or completely forego unit testing. A final caveat is unit testing is a limited scope for finding software defects. Unit testing is done in isolation with the purpose of validating the functionality of a small unit of code and to root out defects in the unit of code. Unit testing by nature is not helpful in detecting system integration or performance defects. Our recommendation on unit testing is just do it. All kidding aside, unit testing is essential to software quality success. We recommend doing as much unit testing as available resources allow, and if safety is paramount, you better test everything. Consider using an agile development method if you want to get exposure to unit testing. An example of this is extreme programming, which is an agile framework that uses test-first programming. Extreme programming uses unit tests to drive the development process forward. Thank you for listening to our presentation on unit testing and have a great day.
Hello, my name is Gregory Mortensen. I'll explain how to unit test. The code under test, or cut, is the functionality we're testing. There are many automated unit testing frameworks like JUnit, NUnit, XUnit, Android, iOS, all of them have unit testing frameworks. The test suite runs the unit tests. Tests that pass are green, failures are red. Notice that the class log analyzer is the cut. It only has one simple method, isValidLog file name. In this code, only a file name that ends with .slf in all caps is a valid file name. In the test, notice the NUnit uses the usual C# decorator pattern. As you see, with stubs, the unit test still directly invokes the cut, and dependencies are stubbed out. However, with mocks, the unit test interacts directly with the mock, not the cut. Again, the log class analyzer is the cut. This time we're testing the analyze method. In this code, only file names with at least 8 characters are valid. Notice that the log analyzer invokes the log error method on the web service if the file name isn't valid. In production, this will write to a text file the Windows event log into a database. In the unit test, we use a mock web service to isolate or only test the cut. In the test, notice that the mock repository uses the function strictMock to create a templatized web service mock. Because it's templatized, you can mock any interface. A mock is like recording a macro. You hit record, do something, and then click stop. Then you replay the macro to execute it. Mocks are considered interaction testing because they test how an object interacts with other objects. When we play back the mock, it confirms the expected interactions occurred. You can also use mocks to return mock data from a database call. Mocking dependencies enables you to isolate exactly where in the dependency tree a fault or failure occurs. In this example, we're verifying the log analyzer sends a log error message to a web service if the file name is too short. Automated unit testing is just that easy. Thank you for listening to our presentation. Have a great day.